I measured the X-ray diffraction as well as electric resistivity, Seebeck coefficient by a steady-state method and thermoconductivity bias. But here, I measured thermal conductivity with two different methods, steady-state method and laser flushing method. So I will explain briefly the differences to them. So this is a laser flushing method. You irradiate the laser into samples, then you detect the temperature. So the time dependence of temperature gives you thermal diffusivity. So you get thermal diffusivity alpha, and finally you get kappa. On the other hand, the steady-state method, this is a setup of the measurement by steady-state method. You put samples on the insulating sapphire glass, and on the top you put a heater. Using a heater, you give temperature differences between higher and lower region. So you get you see the delta T by 2 thermocouples, and you get kappa SS. SS means steady state. So then next I will explain the results. So they are the XRD patterns for 2 samples. As I said, I synthesized 2 samples, 1 and 2. So from these patterns, I calculated the lattice constants A and C. And also, this is a tetragonal lattice, so I calculated the lattice volume. So from lattice volume, I calculated the oxygen deficiency delta. So how? So this is a result of Tojo, who has reported the phase diagram, electron and magnetic phase diagram. So they reported the relationship between the lattice volume and oxygen deficiency delta. So in this case, using this equation, I calculated delta by lattice volume. So in that case, so delta was determined as 0.124 and 0.150. Then I calculated porosity because we did a hot press treatment in order to get low porosity samples. So porosity is calculated by calculated density from the lattice constants and experimental density, such as like fixed length, depth, and width. The result is summarized here. So generally speaking, they are low porosity. Then I could actually they are 2 different directions according to the hot press, initial pressures, vertical and parallel. And I investigated the crystal orientation, so using 003 and 200. According to these measurements, so these 2 are patterns for the 1, 2, 4 phases, but this is parallel setup and vertical setup. And the right 2 figures are for the 150. So in this case, in this measurement, the parallel this setup, this is X-ray diffraction, and this arrow indicates the initial pressing direction. It's parallel. It was weakly oriented towards C-axis. On the other hand, vertical for samples was weakly oriented towards A-axis. Then I will show you the ZT as well as Seebeck coefficient, kappa, and resistivity for the parallel setup and vertical setup. this is just only 0.124 for sample, not 150. So in this slide, please see these figures. This ZT is usually, the practical standard is 1, but this is very low, 10 to the power minus 4. So they are very small. Then I will show you the other sample, 0.150. Here you see some local maximum. But actually, we are thinking that this comes from the magnetism, ferromagnetism, because in this region, this compound shows ferromagnetism. Then I will show you the resistivity. So this is the resistivity for the parallel setup. For the blue one is 1.150 sample, and red one is 124 sample. So this time, in these figures indicates that in order to get a low resistivity, we need to be low oxygen efficiency delta. So this is the same, different direction, but we can say the same thing. So as for the Zivit coefficient, this is very low, which is around 0. Then, actually, this is positive. Some plots are positive, but some plots are negative. So this means the carrier are changing if we suppose the conventional free electron model. But this is sometimes happens, such as the same pre-structure as this compound. Actually, this is reported by Shi in 2009. And this compound is actually the same crystal structure, but this is scandium instead of vanadium. So the left figure is Zivit coefficient, temperature dependence of the Zivit coefficient, and here is the 0. And as you can see, the negative, the change from negative to positive. But actually, I don't know the reason why the origin of the change, the negative to positive. So then I will explain the kappa and the thermal conductivity. So these two shows the kappa SS, with noise. So this one is measured by solid steady state, and this is measured laser flash. So for example, let's compare this red one and this red one, because they are same samples, but the method is different. As you can see, in the laser flash, from 3 to around 4. So around 3 to around 4, like here. So maybe this one is overestimated, or this one is lower estimated. But actually, this comes from the different method. So now it's time, or almost time. So I was gonna. Actually, I tried in the conventional scheme, the Zivit coefficient and inverse of resistivity trade off. So another strategy is using magnetism. So I tried to enhance the Zivit coefficient by ferromagnetism, and actually, in these samples with oxygen efficiency delta equal to 0.150, which is estimated to show the ferromagnetism, and we observe the local maximum. And also the behavior of kappa was different. So it's fine. That's all.
Thank you. Mr. Iwasaki. Yeah, thanks for a good talk. Pardon my ignorance because thermoelectric materials are not my.
Field.
Yeah. You synthesize them with ionic liquids.
No. Actually, this is different. Solid state reaction.
Oh, this is just a solid state from oxides.
Yeah.
Okay, all right. So when you put them in the press, why are you seeing preferred orientation with the?
The reason to.
Yeah, because you're putting a powder into a press.
Mm-hmm.
Why do you get preferred orientation?
Because the purpose of this study is to reveal the intrinsic thermoelectrical properties of this compound. So if you have like pore inside of samples, the pore affected to the Seebeck coefficient or something, etc. So we don't need the pores. We want to diminish.
Yeah. Okay.
Yeah. So that's why.
Intrinsically, is Seebeck coefficient is not related to the pores.
Yeah. Okay.
As other properties related, but
Sorry.
Seebeck
Yes.
is not.
Especially the copper.
You have to check the.
Yeah,
shop.
sure.
Yes. And please explain again.
Okay. So I said. I said Seebeck coefficient is affected to the pore, but it's not true.